Good day. Thank you for joining this training session on voltage drop calculation, which is presented as part of Menasco's mentoring program. My name is Zachariah, and as the lead engineer, and I am going to use an avatar to guide you through today's topic. We'll cover the key concepts, calculation methods, and strategies to manage voltage drops in electrical systems. This session is especially valuable for those early in their careers, so will ensure a solid understanding of the basics alongside advanced engineering details. Now, let's get started.
Slide 2. Class Overview. Our session will introduce the principles of voltage drop, explaining its importance and calculation methods. We'll discuss factors influencing voltage drop, standards like the NEC and IEC, and practical strategies to minimize its impact. Let's dive into why this calculation is so essential for our designs. Slide 3. What is voltage drop? Voltage drop occurs when electrical current flows through a conductor, causing a reduction in voltage between the source and the load. This happens due to the conductor's inherent resistance and reactance. Now, why is this significant? An excessive voltage drop can lead to equipment malfunction, inefficiency, or even overheating, issues we certainly want to avoid in our designs. Furthermore, ensuring compliance with regulations is a critical aspect of our work. Slide 4. Understanding the concept. Voltage drop is a fundamental aspect of circuit design. This formula has been contributed to by James Maxwell, 1831-1879, and Charles Steinmetz, 1865-1923. The formula is a result of applying Ohm's law to AC circuits, along with the principles of phasor analysis. Let's revisit the formula as shown here, where V drop means voltage drop, I is the current in amps, R is the resistance of the conductor, X is the reactance, and theta is the phase angle between voltage and current. This formula combines resistance and reactance components to quantify how much voltage is lost. Slide 5. Factors affecting voltage drop. To understand voltage drop better, consider these key factors. Conductor size. A larger Crow SS sectional area reduces resistance. Conductor length. Longer runs increase resistance, resulting in more voltage loss. Current load. Higher current demands lead to higher voltage drops. Material. Copper has lower resistance compared to aluminum, which is why it's often preferred. Temperature. As temperature rises, so does the resistance of the conductor. Slide 6. Step-by-step calculation. Here's how we calculate voltage drop. Determine current, I. Use the electrical load to establish the current. Conductor specs. Gather resistance and reactance values based on your conductor's material. Measure conductor length. The total distance from the power source to the load and back. Apply the formula. Plug your values into the formula. Check limits. Ensure your result stays within acceptable voltage drop ranges. Here in the UAE, including all Emirates, the national allowable limit is 4%. Please keep this in mind when making all your calculations and as you engineer systems at site. Slide 7. Example. Calculation. Let's work through a practical example. Take a moment to look at the data below and the results based on the calculation step. Please go back to slide 4 and use the data found here to solve that formula. Your results should match the results listed here. It might help to pause the video at this point while you work through the formula. Slide 8. Standards and guidelines. The NEC and IEC provide clear guidelines for voltage drop. NEC. Voltage drop should not exceed 3% for feeders and 5% for branch circuits. IEC. Similar recommendations apply. Exceeding these limits can compromise equipment performance, safety, and lead to overheating or failures. Slide 9. Minimizing voltage drop. Here are some engineering strategies to mitigate voltage drop. Larger conductor sizes reduces resistance. Shorter lengths minimizes the distance over which voltage is lost. High conductivity materials. Opt for copper when possible. Load management. Balance the load across circuits. Increase voltage levels. This can make voltage drop relatively less significant. Slide 10. Calculation tools. Fortunately, there are many tools to simplify these calculations. Software, ETAP, SKM Power Tools, and PowerWorld are popular in our industry. Online calculators. Many are provided by manufacturers for quick estimates. Manual calculations. As we did today, always useful for spot checks or simpler systems. Slide 11. Conclusion. In summary, understanding and managing voltage drop is crucial to the efficiency and safety of electrical systems. By mastering these calculations, we ensure our designs meet regulatory standards and operate reliably. Remember to always consider voltage drop in your projects to prevent costly issues down the line. Slide 12. Q&A. That wraps up our session. Thank you for your attention. Are there any questions or areas you'd like me to elaborate on? If so, you can email me at ed.smith@menascodubai.com. Thank you again for attending a Menasco mentoring and training session.